Hi everyone, welcome to my YouTube channel's Advanced Learning Center. Go through the playlist to know better about about the videos in my channels. So this is the disclaimer of my videos. Please go through this one. So today we are going to discuss about the analog electronic subject AE1 semester third and question paper of the year 2022. This was came on end semester examination in State Council of Technical Education Assam, that means in all polytechnics of Assam. Myself Dashar Ali Sheikh. So contents of today's videos: AE1 question paper of 2022 State Council of Technical Education, solution of AE1 part A, solution of question number 1 fill in the blanks, solutions of question number 2 write true or false, solution of question number 3 choose the correct answer. So these are the question paper that was came in end semester examinations 2022 semester third, branch electronics and telecommunication engineering, subject code 305, subject is analog electronics 1, full marks is 70, duration is 3 hours. So there are two parts, part A and part B. In part A there are 25 marks. There are 3 questions, 10 marks for fill in the blanks, 10 marks is true or false, and 5 marks for choose the correct answer. So one by one questions we will be discussing in our later slide. So now we are going to, you have see that in the first question they are fill in the blanks, 10 marks. Next, in the question number 2, there is to write true or false. There is also 10 question, 10 marks is there. You have to write down whether the statement is true or false. Next is choose the correct answer. There is 5 questions. So from the multiple options, we have to select out the find out the correct answer. Next is part B. In part B, there are 45 marks is there. This is the all are descriptive type. So this short question will be described later. So read the instruction given for each questions. Answer the following questions. Define intensing and extrinsic semiconductors. Draw the symbol of Brechter and Schottky diodes. Draw the output characteristics of NPN transistor in a configuration. C means common emitter configurations. Question number D. What do you understand by Q point of a transistor? Question number E. What is crossover distortion? In question number 5, they are asking about answer any 5 questions. So explain in brief atomic bonding in the semiconductors. Explain in brief the working of a PN junction diode under reverse bias conditions. Derive an expressions to find out the maximum efficiency of the full wave rectifier circuit. Explain in brief the construction of NPN transistor. Question number E. Calculate the emitter current I in a transistor for which the base current IB equal to 20 microamperes and beta equal to 50. Write the difference between BJT and JFET. Draw the frequency response curve of the RC coupled amplifier. Write one applications of RC coupled amplifier. Question number 6, any 4, that means 5 of each. Explain insulator, semiconductor and conductors with the help of energy band diagram. How is Zener breakdown different from the avalanche breakdown? Explain Zener diode as a voltage regulator. Explain diode clamping circuit with necessary diagram. Explain the working of an NPN JFET junction fill effect transistor. Explain the circuit operation of class B push-pull amplifier. Write short note on any two solar cell filter circuit and load lines. So now we are going to give the complete solutions of question number 1, fill in the blanks. So first question, see the first questions of question number 1A. The number of valence electron in a semiconductor silicon atom is 4. So see how it is 4. As we know that the valence electron is nothing but is the outer shell electron. As we think the atoms that will be participate in forming the chemical bonding if the outer shell is not closed. So all atoms in the bond added 1 electrons in a single covalent bond. So as per the Bohr's atomic models, the serial number of silicon is 14. So 14 means in the periodic table. So as we know that in the balanced electron shell there are 7 shell is there from 1 to 7. In the first it is 2 electrons, second 8 electrons, third 8 electrons, fourth and fifth 18 18, 6 and 7 32 32. So as we have 14, so the electron distribution will be 2 8. It is how much? 10. 2 plus 8 means 10. So remaining how many electrons are there? 4 electrons are there. So 4 will be in the outermost shell electrons. So as per this balance electron shell distributions, so there are 4 electrons in the outermost shell of the silicon atoms in the valence electrons. So that's why the answer is 4. Okay. So next question 1b, dash are the majority charge carrier in p-type semiconductor, holes are the majority charge majority charge carrier in the p-type semiconductor, because here is holes, here is electrons. Okay, in n-type it is electron are majority, p-type it is holes are the majority. So LED stand for light emitting diodes. Why it is called light emitting diodes? If you see in the symbols of the LED diodes, these symbols are nothing but is the emitting of lights. So that's why this called the light emitting diodes. He has two terminals, anode and cathode. So question number 1D, the refill factor of full wave rectifier is 0.482. Sometimes it is written 48. Sometimes two are not written, so that both are correct answer. Okay. Next is BJT, bipolar junction transistor has three dash terminal. Bipolar junction terminal has three terminals called base, collector and emitter. So here see that this is the BJT, bipolar junction transistor. It has three terminals, emitter, base and collector. Okay, in NP and PNP in both the cases. Next is question number 1F, emitter of a transistor is dashly dropped. That means emitter of the transistor are heavily dropped. Okay, the next question 1G, the value of alpha in a transistor is always less than 1. So alpha, if I have noticed, the alpha values is always less than 1 and beta values is always greater than 1. Beta value 99, 59 like that it have written, but alpha value 4.99 something like this, 4.98 like that is written. So alpha values is less than 1 or unity. UJT has dash PN junction. UJT means uni-junction transistor. Uni-junction means there are one junction is there, so there are only one PN junctions. Okay. Next is JFET. JFET means junction field effect transistor is a dash control device. It is a voltage control. Next is 1J dash is a coupling is used for amplifying extremely low frequency signals. So direct coupling are we have used for amplifying the extremely low frequency signal. So question number 2 now, solution of question number 2, right, true or false. So see the first question 2A, the valence band and the conduction band overlap each other in the case of insulator. This statement is false because in the conduction bands the valence band and conduction bands are far away from each other, so they are not going to merge, that means not going to overlap. So that's why it is called, this statement is false, because the valence band and conduction band overlap with each other. That means electrons can easily jump from one electrons to conduction band. Hence, the conductivity of conductors is high. Next question is reverse saturation current. In reverse saturation current, direct flow, the majority charge. So this statement is also false. In reverse bias PN junction diode, due to increase of depletion layer, it is almost impossible for majority carriers to cross the junction. Hence no current is flow, because in the reverse bias situation what happens, the depletion layer will be, the width of the depletion layer will be increased. So this is called the depletion layer, p type, and this is n type. So in the depletion layer width will be increased, so that majority current will be not able to pass. So this is because of the minority carriers can pass. So that's why it is called the this statement is called false. Next question is Jenner diode has sharp breakdown voltage. So this statement is true because in the figure, if you have see that one word is missing here, one word should be there, that is in negative voltage. Zener diode has sharp breakdown voltage in negative voltage. They have to write, but unfortunately they have uh, missing this word, that is negative term. So in the negative voltage, so here is also negative, here is also no. So negative, in the negative terms, what happens? It is almost sharp. Here it is in increasing order, but in the reverse breakdown, reverse voltage, that means negative voltage, it is almost sharp, that is almost constant. Okay, so next question is Schottky diodes have a very fast switching action. So this statement is true because Schottky diode has very fast switching actions. Next, negative clamper circuit push the signals upward. This statement is false because if you see in the positive clamper circuit, this is the input start from 0. So this is the sinusoidal signal, this is the positive clamper circuit. Here start from B open. Okay, so B 0 to BM, from BM start, 0 is the lower terminals, in the upper terminals is twice M. So it is shifted upwards in the case of positive clamper circuit, not in the negative clamper circuit. Negative clamper circuit, what happens in the negative clamper circuit? This is the positive plus volt minus volt. See, here it is start from minus BM. So it is coming uh, shifting downwards, not upwards. So this statement is false. So next question, a full wave bridge rectifier does not require a center type transformer for its operation, because this statement is true because there are 4 diode used. That diode is also itself work as a center type transformer, so it does not require extra center type for the operation of the full wave bridge rectifier circuit. Thermistor can be used for bias compensations in a transistor. This statement is true. Collector current is the sum of emitter current and base current. This statement is false because in emitter is equal to IB plus IC. Now see this diagram. So here is IE current is incoming for the case of NPN transistor, and IB and IC are outgoing. So if you apply the KCL, it's a current law. So outgoing incoming current is equal to incoming current is IE, outgoing current is IB plus IC. So here is also NPN transistor. I is the outgoing current, IB and IC are the incoming. So incoming current equal to outgoing current. So this is the correct equation. So this statement is false. Okay. So next is MOSFET. Metal oxide semiconductor field effect transistor is a unipolar device. This statement is true. So this it's always follow the current from source to drain. Okay, so this statement is uh, true, or drain to source. So it is unipolar. It's follow the current only in one direction. So transformer coupling is used for impedance matching. This statement is also true because for impedance matching, transformer coupling is generally used. Next is solution of question number 3. Choose the correct answers. 3A, the resistivity of the conductor of a semiconductor is what? It is more than an insulator, less than an insulator, equal to an insulator, or none of the above. So resistivity of the semiconductor is always less than an insulator because the resistivity order is insulator is highest, then semiconductor, then conductor. So for semiconductor, this will be less. So that's why our correct answer is this one. That means less than insulator. Next is when a PN junction diode is reverse biased, the width of the depletion layer is increased. In the earlier slide also we have seen that when the PN junction is reverse biased, so P type, suppose this is P type, and N type, so this is N type, suppose this is P type, so this is the depletion layer. So this width is what happens, this increases. on the current is reverse bias. Okay, so on the current is reverse bias, that times what happens, width of the depletion layer is increased. So this is the correct answer. Next question is, maximum efficiency of the half wave rectifier is 100%, 81.2%, 50%, 40.6%. So for half wave rectifier, maximum efficiency is 40.6%. So the most widely used method of providing biasing and stabilizations to a transistor is base bias, collector feedback bias, emitter feedback bias, potential divider bias. So potential divider bias is the correct answer for mostly wide used for providing biasing and stabilization of a potential divider bias. Widely used. Then last questions of the 3A, the collector current flow all the times during the full cycle of a signals dash power amplifier, class A amplifier, class B amplifier, or class C amplifier. So class A amplifier is the collector current flow all the time during the full cycle of the signals. So that is correct answer is class A amplifier. So thank you for watching this video. Please subscribe and like these videos. If you have any questions, you can put your questions on the comment sections. And another thing is part B we have not described. So if you want the part B descriptions, we will be try to give the full descriptions of the part B too. So if you need, please uh, write on the comment sections, and please subscribe our channels. So thank you.